All right, so back to it. Sorry that this had to be split up in two, so it's kind of longer, but lots of good things to know about currents. So far, we've gone through surface currents and how they are a result of the wind interactions with the water. So the wind is blowing along as the wind, because the wind moves in circular motions around the earth as well due to the Coriolis effect. As that wind moves in a circular motion, it pulls the top part of the water along with it, and we say that this flows horizontally. We talked about the gyri, that there are 5 of them, and they're again run by that cool and warm current kind of movement and the Coriolis effect of the winds. And we talked about how the warm ocean currents can actually affect the climates of the land masses that they are passing as they go through their regular motion. Happens in specific examples. This happens because in Great Britain because of the Gulf Stream as it flows past the nation of Britain, which again is a little island. And we talked about temperatures and how the water interactions right here can kind of stabilize the temperature, causing it to be warmer than longer, more mild temperatures. So it's warmer for longer. We don't have as drastic of a temperature switch. Although, again, latitude, so how north you are from the equator, how south you are from the equator also affects your temperature and climate as well. But now we're getting into the nitty-gritty of the deep or the density-driven currents. So one reason that we spent so much time last week studying temperature's effect and salinity's effect on density was because this is how the deep water currents are created. So they're actually vertical currents. So while the surface currents were horizontal across the surface of the water, these deep density currents actually go through the water column, and it's because of because of the water temperature. So as it cools, it sinks. Remember from our experiment, the blue water that we made really cold would sink in the room temperature water, meaning that it was more dense. So that is one reason why it goes down, it sinks. And then as we change our salinity of the waters, a water sample that has a higher salinity is actually going to have a higher density as well. So temperature has this is important, I would write this down. Temperature has a indirect relationship with density, meaning that as temperature increases or my water gets warmer, I'm going to have a smaller density. I'm going to decrease my density, meaning that I'm going to rise. In contrast, if my temperature is decreasing or it's getting colder, my density is increasing, meaning that that water sample is more likely to sink. Salinity, though, in contrast again, has a direct relationship with density. So as I increase my salinity, the density of the water sample is also increased as well. Very clearly stated there in that last bullet point. Highlight it, draw some stars around it, do something. Decreasing temperature and increasing salinity causes water to become more dense. When things are more dense, we see sinking. So our evidence to support this is that the water sinks. Deep currents, so near the Antarctic surface conditions create the highest density water in the world. So we have very salty, very cold water. You can see that this is the bottom of the globe if you've never seen it before. This is what it looks like. So right around Antarctica here we have the highest density because it is the coldest, and also as the liquid water turns to solid water, typically the salt does not go with it, so we have leftover salt as well. So we have the densest water in the whole wide world is found near Antarctica. Deep currents, evaporation results in an increased salinity, so that increases the water density. A simplified model of ocean circulation is called the conveyor belt. This is what we call the global conveyor belt. It is a density-driven current system, and it's what we see through the world. That density-driven global conveyor belt can also transfer cold temperatures and warm temperatures to the surrounding land that it passes by. So if you were standing here, maybe South America, maybe let's see here Florida, we've got the warm temperatures coming from this warm current and warming up the land, while in contrast it goes, and as it travels up the latitude, it gets colder and colder and colder until it starts to sink again, and then goes back past parts of Canada right there, and brings with it cool water, cool temperatures. Last thing I wanted to talk about with ocean movement is actually called upwelling. Upwelling is the rising of cold water from deeper layers to replace the warmer surface water. Wind blows the warm surface water away and is replaced by cold water. And if you didn't know, cold water, or the water coming from the bottom of the ocean, is actually chock full of nutrients. So this upwelling is really, really good for aquatic saltwater ecosystems. Without it, we get a lack of oxygen in our water. So if we don't have oxygen in the water, the fish can't breathe, and then they end up dying. It also brings just different kind of sea life a little bit with it, maybe some nutrients that plants need as well. This is all because the wind blows that warm water away. If you can see right here, the wind's coming in, and it's going to blow the surface water and move it away, and then it's going to be replaced by this cold water, or what we call upwelling, that has lots of nutrients, and it's going to be very beneficial for whatever ecosystem is right here. This will only happen where you've got to have this land here, so like this wouldn't happen if all of this was water. The land is creating the place for the cold water to kind of come up and rise through. So it's kind of like think of it like a ramp. If the ramp wasn't there, the upwelling would not happen. It'd just be replaced by more surface water. So this can only happen where the continent or land meets the ocean. Deep water, like I said, is very rich in nutrients and is brought to the surface when we have upwelling. Here's just another diagram of it. So as the surface water moves offshore here from the wind, nutrient-rich water moves up towards the surface of the water in a process that we call upwelling. What is the impact of upwelling? Upwelling, like I said, revitalizes the ocean and keeps it pretty healthy. So without it, we would not have the ecosystem. It's kind of like a reset button. If you don't have that nutrient-rich water, the water that you once had was really, where's the good picture of it? This water right here, the warm water, is very low in nutrients, so the ecosystem would have, at the very least, trouble surviving. At the most, maybe it would cause ecosystem death. And then this is for another day. So have a good day. This is the end of the notes. Submit the sheet of notes, and we will get picking back up with this tomorrow. Goodbye.